Okay, good morning, everybody. It's good to see you all. You might notice we've had some equipment upgrades in here, so we're very excited about that. This morning, we have Dr. Calvin Beisner with us again, and he's going to be talking about the topic of climate change this morning. So, how about I begin our time with prayer, and then I'll hand it over to Cal. Let's pray. Heavenly Father, we do thank you for this time that we have together in these Sunday school classes to explore your truth, your word, and your world. I pray, Lord, that you would bless our time this morning, that you would give us wisdom and discernment as we navigate difficult and controversial topics. And I pray, Lord, for your blessing on Dr. Beisner and his lecture this morning. I pray that we would all be edified and that we would all be encouraged in our desire to honor you with our whole lives. In Christ's name we pray. Amen.
Amen. Well, thank you very much for coming this morning. It's great to be back with you. I have a lot of slides to get through this morning, a whole lot of information I hope to get across, and so I'm going to be going pretty quickly. Still hope to have some time for question and answer at the end. I would just point out to you that there are lots of materials on two tables back here. Both tables have all the same stuff, so you don't have to worry too much about crowding. And we simply ask for donations. There's no price on anything. You're not buying anything. If you want anything from there, please take it. I'd love for you to take everything from the table. That would be just great. And if you did that and nothing came in donations, that would be okay too. The only thing that we do particularly ask about is the big fat book, Climate and Energy, The Case for Realism, which we suggest a donation of $30 about that one. But everything is free to you because our aim is to get information out. This is a very complicated subject, and I'll tell you, I've spent 30-some years studying this, done a lot more study on the science of climate change than I did for my PhD at the University of St. Andrews in history. So it's going to be fun. We'll see how we can do here. Let's see. Our book is titled Climate and Energy, The Case for Realism. Why do we use the word realism? Well, it's because our view is different from two sort of opposite extremes. At the one extreme, you have the very widespread view, heard constantly in the media, constantly from politicians, that climate change driven by human activity is real. It is overwhelmingly driven by human activity. Natural variation has very little to do with it. It is very dangerous. It's already bringing catastrophic results around the world. It's going to bring much worse results. It can even be an existential threat. And therefore, we need to spend trillions of dollars completely revamping the entire world's system of providing energy and food and transportation and everything else to stop this, because if we don't, well, humanity could go extinct by the end of this century, or maybe by 2050, or maybe by 2035, or you'll find all sorts of different numbers. That's what I would call the climate alarmist position. And at the opposite end of the spectrum is the climate hoax position or the climate denier position, and that says, well, yeah, climate changes naturally, but human activity has absolutely no influence on it, and there's no problem, there are no difficulties to be encountered with climate change. All of this is just a hoax driven by political ideology and the desire to bring about one world government, to further human population control, and so on. And there's just zero to worry about. I think both of those perspectives are mistaken. What I think, and this is the perspective, frankly, of the vast majority of climate scientists, although you'll never catch that from how the media handles things, is that Yeah, human-induced climate change is real. The global average temperature has risen by about 1 to 1.2 degrees Celsius since about 1850. There are some problems that come with that, but there are also some benefits that come with both the temperature change and the increase of carbon dioxide in the atmosphere and its effect on plant growth around the world, which is highly positive. We can deal with the problems at a reasonable cost. We can also cause enormous harm if we try to implement the prescriptions given to us by the alarmist sort of movement. So I try to think of our perspective on this as climate and energy policy fit for Goldilocks. Not too hot, not too cold, just right. I want to just give you very quickly some biblical foundations here. In my very first lecture, I spent a good deal of time on this, and so I don't want to go into depth because we have so much to cover. And I'm just going to give you a few verses here. In Genesis 1:31, we read that when God had made everything, he saw it, and behold, it was very good. And I'd like you to ask yourself, will raising CO2 concentration from 27 thousandths of 1% of the atmosphere, which is what it was before the Industrial Revolution, to 54 thousandths of 1% of the atmosphere, which is what it might be by the end of this century, should we expect, if indeed all of God's creation is very good, that that would cause catastrophic results? I think that that puts together a cause that is minuscule compared with an effect that is huge. And that doesn't make much sense to me. Second, in Genesis 1:28, we have the dominion mandate where God blesses Adam and Eve and says to them, "Be fruitful and multiply and fill the earth and subdue it and have dominion over, well, everything in it, in the sea, in the air, and on the land." And yet, most of the environmentalist movement, and certainly many people in the climate alarmist movement, think that humanity should minimize its influence on the natural realm. We should minimize our carbon footprint, for instance. You want to have the tiniest carbon footprint you can possibly have. That is, you don't want a lot of carbon dioxide being emitted because of the things that you do, because that carbon dioxide increase is causing catastrophe, right? Does that match up well with God's instruction that we are supposed to subdue and rule the whole world? I have some difficulty with that. Genesis 8:22 says that God, following the flood, said to himself, a promise to himself, a covenant with himself, "As long as the earth endures, seed time and harvest, cold and heat, summer and winter," what was the other one? "Night and day, will not cease." That's a Hebrew poetic device called merism, in which you get opposites of an extreme, and by piling four opposites of four extremes on top of each other, what it's saying is, yeah, that and everything else in between. God is promising that he will sustain all the cycles on which human and other life depends. Is it consistent with that for us to think that raising CO2 from 27 thousandths of 1% to 54 thousandths of 1% in the atmosphere is going to cause huge problems with these cycles? I don't think so. In Psalm 104, verses 5 through 9, we read that God set the boundary for the sea following the flood. He set a boundary for the sea that it could not pass over that. Now, I think that's very consistent with thinking that sea level can rise and fall by certain amounts. But the notion that we're going to have, as I'll show you in a slide later on, 20 feet of sea level rise that's going to wipe out all of South Florida within a reasonably short period of time, driven by our emissions of CO2, how sensible is that? Does that really fit with a biblical understanding of God's faithfulness? And then Galatians 2:10, Paul says that when he went to visit the apostles in Jerusalem early in his ministry, he says, "The only thing they asked me to do was to remember the poor, which I was already intent on doing." And what got me into all of this was that as an economist, I recognized, starting in the late 1980s, that a great deal of environmentalist policy was very harmful to the poor around the world. Environmentalists tend to think that as population grows and as affluence grows and as technology increases, the negative impact on the environment will increase. That's actually a formula that Paul Ehrlich devised. I equals PAT. Impact equals population times affluence times technology. And that means that if you care about the natural world, you want to reduce population, you want to reduce affluence, you want to reduce technology. Now, I think that the empirical evidence is precisely the opposite. I won't go into that question much today, but here's where this is relevant. Almost everything we are being asked to do to slow, stop, or reverse human-induced global warming is stuff that will slow, stop, or reverse the conquest of poverty around the world. And poverty is a far greater threat to human life and health than anything related to climate and weather. Anything. Over the last century, the annual rate of human mortality driven by extreme weather events fell by more than 99%. And it's not because the number and intensity of extreme weather events fell. It didn't. Didn't rise either, by the way. It's because people grew richer and richer and able to protect themselves from those things. So that's what motivates my having gotten so involved in these things, though my principal love is theology and apologetics and evangelism. Okay, so let me just try to dispel a little myth. We all are used to seeing in our media, from our politicians, the constant claim that human-induced climate change is real and catastrophic. Well, Dr. Judith Curry was the chair of the Department of Earth and Atmospheric Sciences at Georgia State University for many, many years. She's one of the world's leading climate scientists, and she released a book last summer, called Climate Uncertainty and Risk. And in that, she says, here are the incontrovertible facts about global warming. 1, average global temperatures have overall increased since 1860. 2, carbon dioxide has infrared emission spectra. That means it absorbs infrared, that is heat, as it bounces from Earth's surface back out towards space. It has infrared emission spectra. It absorbs some of that heat. It releases it back, some of it continuing out, some of it back down toward the surface, and thus it acts to warm the planet. 3rd, humans have been adding CO2 to the atmosphere via emissions from burning fossil fuels. Those 3 points, there is no disagreement among scientists about those. No significant disagreement. But what climate scientists don't know may be what you think they know, at least if you've been believing the media. These 3 facts, either individually or collectively, do not tell us much about the most consequential issues associated with climate change. First, whether and to what extent CO2 and other human-caused emissions have dominated over natural climate variability as the cause of recent warming. We know from geologic history that the Earth has warmed and cooled repeatedly through history. How do we know that what's going on now is overwhelmingly or exclusively or even minimally driven by human activity? We simply don't. We have some pretty good ideas, but we don't know. Second, how much the climate can be expected to change over the 21st century. People are telling us, we're going to have 4 degrees Celsius of global warming if we don't stop using fossil fuels. There is no agreement among scientists about anything like that. We have no idea how much warming will happen. I'll tell you later some of why. We don't know whether warming is dangerous. Isn't that a shock? Everything we hear about it it's bad. Real scientists don't know that. And we don't know whether radically reducing CO2 emissions will improve human well-being in the 21st century. All of those things are the standard message of the climate alarmist movement. But she's saying climate scientists do not know those things. And she's right. Okay, nonetheless, we get a lot of scare tactics. And I'm going to give you a few and tell you a little bit about how to overcome them. Some of you might remember back in 2001, Time magazine had this cover, the Earth pictured as the yolk of an egg frying in a pan, and we're going to fry, right? Well, just for fun, eggs start to fry at 158 degrees Fahrenheit. Average global temperature is about 60 degrees Fahrenheit, rising 0.27 degree per decade, which is roughly what it's been doing since 1979. It would take 3,629 years for that egg to start to fry. All right. Now, it's hyperbole, right? But you have to ask yourself, why use such hyperbole, if not just to scare people where the facts won't necessarily scare? In 2021, BBC News said climate change. IPCC report is, quote, code red for humanity, unquote. They were quoting UN Secretary General Guterres there, and he said that when the sixth assessment report of the Intergovernmental Panel on Climate Change came out, code red for humanity. You will not find that language anywhere in the IPCC's report. You will not find the words crisis or existential threat or catastrophe in the IPCC's report. The only place where you do is in a source note, a reference note, that criticizes a media source for using that language. It's the only place. Or in his second State of the Union address, Biden called climate change an existential threat. Well, here's how NOAA uses data to scare you. Notice, this is supposedly the change, and it's reasonably accurate. I don't contest this at all. But this is the change in global average temperature from 1880 to 2022, I think this one ended. And that's reasonably accurate. But note the y-axis, that's the perpendicular axis. It's 1.5 degrees Celsius, or 2.7 degrees Fahrenheit. And note the choice of colors. Dangerous red, cool blue. As if colder is better, warmer is worse, right? Now, NOAA isn't honest enough to put those two notes in the middle there. I put those in, right? NOAA depends on the fact that the vast majority of people who see graphs like this never look carefully at the y-axis to see how broad it is, right? But that's NOAA for you. That's National Oceanic and Atmospheric Administration. Here are exactly the same data, exactly the same numbers. But that's not nearly so scary, is it? Because it's all one color in a very simple way. There are ways to frighten with numbers without telling lies. And that's what happens. Now, here are exactly the same data with a different y-axis, a different perpendicular axis. This one is a 20 degree Celsius, 36 degree Fahrenheit y-axis. Why did I choose that? That's a reasonably typical difference between nighttime low and daytime high in most places around the world. We don't get upset about that, do we? Why should we get upset about 2.7 degrees Fahrenheit change in global average temperature? By the way, nobody experiences global average temperature. The only temperature you ever experience is where you are. It's not the whole globe. Global average temperature is irrelevant to any ecosystem and to human life. Unless, of course, it goes up by several hundred degrees, in which case, yeah, we'll all fry, but nobody thinks it's going to do that. Okay, let's see. And then we can put it, just for fun, on an axis from absolute zero, minus 273 degrees Kelvin, to the hottest atmospheric temperature ever measured on Earth, which is actually 330 degrees, but the spreadsheet wouldn't allow me to do that, so it's 327 there. And the straight blue line across the top, that's the same data that you saw in Noah's graph. So there are a lot of issues about how to be honest with data, with graphs. Okay, here's another scare tactic. Heat waves. Fair and balanced, right? Fox News. Weather maps in mid-June. Okay, so last month. Notice all that deep red all over the northeast United States, right? Whoops. How did I go backward? All right, potential record highs, the forecast for the east, all of these highs. That's what they show, right? Same day was this. This is what they don't show at fair and balanced Fox News, right? Now, this was annotated by a meteorologist named Martz, and he's pointing out climate change, the red area, gets blamed for that red, right? But the rest is just weather, right? Well, so this is how Martz comments on that. Anyone who has passed a high school physics course understands Newton's third law of motion, which states that for every action there will be an equal and opposite reaction. Any area of unusual warmth is going to be balanced by an area of unusual cold. The 2-meter air temperature anomaly, that's the height at which air temperature is typically measured, that is the departure from average, map for the last 5 days conveys this quite well. The upper plains and Canadian prairies have been averaging generally some 6 to 12 degrees Fahrenheit below average, while the Great Lakes, Ontario, Quebec, and New England have been 6 to 12 degrees Fahrenheit above the average for 1991 to 2020. The entire map area anomaly is 0.5 degrees Fahrenheit, and if the entire map were colored according to that value, what color would it be? White. While slightly above average, yes, it's not at all significant. But did you know that Western North America is quite cool relative to average of late? No. Why? Because the news media would rather fixate on the heat wave in the eastern U.S. and southeastern Canada to spread fear over typical summer weather. That's essentially what it boils down to. Boils is an appropriate term. Okay. What you're also not told is that cold kills a whole lot more people than heat does. On average, a cold snap kills 10 to 20, the best data are more toward the 20 end of that, 10 to 20 times as many people per day as heat snaps, heat waves, right? Now, what that means is that if global warming reduces cold snaps, even if it increases heat waves just as much, which, by the way, it doesn't, for reasons I'll tell you later, you would see a reduction in human mortality from temperature-related problems. Greenhouse gas warming is mainly toward the poles in winter at night. So it raises low temperatures much more than it does high temperatures. And the result is a large net reduction in human mortality. Okay, scare tactic number 3. There's going to be more extreme weather because of all of this. For example, the BBC just recently reported, Hurricane Beryl, record-breaking sign of warming world. Right? Hurricane Beryl is wreaking havoc in parts of the Caribbean and putting the role of climate change under the spotlight. With maximum sustained wind speeds of more than 160 miles per hour, it became the earliest Category 5 Atlantic hurricane in records going back around 100 years. In fact, there has only been one previous recorded case of a Category 5 Atlantic hurricane in July, Hurricane Emily on 16 July of 2005. That is by Mark Pointing, who is a climate reporter for BBC. Now, Mark's qualifications are that he has a master's, not in climatology, but in polar studies of glaciology and geology, and a bachelor's in geography. What he's forgetting is that hurricanes are weather. They are not climate. Climate is average weather over a period of at least 30 years over a very large region or the globe as a whole. Weather is what happens over a few days in a local area. Hurricanes are weather. They are not climate. And no hurricane is a sign of anything about what's happening with climate, let alone with global average temperature. Now, there are records and there are records. Dr. Roy Spencer, who's a principal research scientist in climate science at the University of Alabama, he's on my board, he's a senior fellow, he's written a couple of books that are available on the table over there. Please take them for free. Roy says, in response to BBC's report on this and other reports, very similar all over the world, I have a question about Hurricane Beryl being the earliest Atlantic Cat 4, Cat 5 hurricane on record. If this same storm occurred 100 years ago, in 1924, would it have been documented as a Cat 4 or Cat 5? No, because the data did not exist, and it was located in the middle of nowhere. Ships of opportunity would have sailed around it or be sunk. There were years when dozens of ships were sunk by hurricanes 500 years ago, but no one really knows their intensity. We simply don't know whether there were hurricanes even as much as, say, 60 years ago in July or June that were that strong. And so calling it a record, yeah, it's true, but it's also misleading. Okay, does global warming increase hurricanes? As I said earlier, greenhouse gas-induced warming happens mostly toward the poles in winter at night, not toward the equator in summer in daytime. Therefore, it reduces the temperature gradient between the equator and the poles. Now, hurricanes move heat from the equator to the poles. Reduced temperature gradient results in less need to move that heat, and therefore in potentially fewer, but much more importantly, weaker hurricanes. When I said that, by the way, on some news program back in 2006, a bunch of people just went ballistic saying what an idiot I was. And I got a phone call in my office at Knox Theological Seminary, and the guy starts off saying, "You don't know me, but my name is Neil Frank, and I was the longest-serving director of the National Hurricane Center." And I thought, oh no, I really bit it this time. And he said, "I called to tell you, stick by your guns. You're absolutely right." Neil has since become a supporter of the Cornwall Alliance, and he's done a lot of lecturing for us and so on. Wonderful, godly man. All right, the observation is that empirical data do not show any increase in the frequency or intensity of hurricanes or any other weather, extreme weather, floods, droughts, heat waves, cold snaps, wildfires, anything like that. There is, in terms of actual real-world observation, no increase in those over the last 60, 70, 80 years, during which supposedly we've watched serious greenhouse-induced global warming. This is the trend in hurricane frequency. The upper line is all hurricanes. The lower line is major hurricanes. And while there's lots of interannual variation, there is zero trend here, unless maybe you start your count in the mid-1990s, and then there's a downward trend from there. But what we've given is the longest data that can be had that are reasonably comparable. Here is the trend in accumulated cyclone energy. How much energy in all of these hurricanes? And again, interannual variation, no clear trend whatsoever. So when you hear the media tell you, oh, we're having more and stronger hurricanes, false. It's just false. Okay, scare tactic number 4. But we'll all drown. So Al Gore says in An Inconvenient Truth, the movie, that he's illustrating the effect of a 20-foot rise in sea level on South Florida, where roughly 15 million people live. And to critique that, we point out the average rate of sea level rise, SLR, 1900 to the present, was about 1.8 millimeter per year. there has been no apparent acceleration of that rate. The best evidence, instead, is for a slight deceleration in the rate of sea level rise. It's still rising, but it seems to be rising ever so slightly more slowly. The time to achieve 20 feet of sea level rise, therefore, is 6,096 years. That's when South Florida will be uninhabitable. When I lived in South Florida, 15 miles from the beach, 8 feet above sea level, I applied the UN Intergovernmental Panel on Climate Change's predictions of how fast sea level rise would apply to my house, and I found that I'd have beachfront property worth far more than it already was in approximately 3,600 years. Or another way of putting this from the site justfacts.com, a 20-foot rise in sea level equals 8 to 34 times the full range of 110-year projections for sea level rise in the IPCC's 2007 assessment report. So Gore says 20 feet. He doesn't say anything about how soon. That scares people, and they're not getting the facts. Okay. Scare tactic number 5. But CO2! CO2, it's a pollutant. We need to reduce our emissions of CO2. All right, well, in this graph, the solid red line is the average of all coupled model intercomparison project Generation 5 climate models as to how much change there should be in global average temperature due to increasing carbon dioxide over the period from 1979 to 2023, I think it was. And that's the average of them. The little thin colored lines are the average of individual CMIP-5 model groups, and the solid figures are weather balloon, satellite, and reanalysis data for the tropical troposphere. That's the boxes are real-world observations, not models. That's what we actually see, right? Only one of the 32 model groups runs correctly simulates what has been observed. It's the Russian model INM-CM4, which has the least prospective warming. Now, because of that, sound science would use that model for predicting future temperature instead of the average of all the models. The IPCC doesn't do that. It uses the average. Well, the average exceeds the observations by 2 to 3 times. Okay, here's another one. The next generation of the models was even farther from right than the earlier generation, after spending literally billions of dollars trying to improve them. You'd think that if it were real science, we'd have an improvement. Instead, we have a deterioration. Okay. CO2's big effect is not on temperature. It's actually quite small. It's real. I'm totally convinced it's real, but I think it's probably on the order of around 1 degree, maybe half a degree Celsius for every doubling of CO2. That's lower than the IPCC thinks. I think there are good reasons for being there. But the big effect of CO2 is on vegetation. This is, I just went to Google and I asked, I asked for increased vegetative cover from CO2. All right? And here is what Google's AI responded. According to a 2016 study published in Nature Climate Change, rising carbon dioxide levels in the atmosphere have led to a significant greening of 25 to 50% of the Earth's vegetated lands over the past 35 years. This greening is equivalent to an increase in leaves on plants and trees that's twice the size of the continental United States. The study estimates that 70% of the extra green growth is due to rising CO2 levels. That's wonderful. That's really amazing. Think about this. This is how CO2 affects plants. Every doubling of CO2 concentration in plants causes 35% average increased plant growth efficiency, better growth in warmer and cooler temperatures, better growth in wetter and drier soils, better use of soil nutrients, and better resistance to diseases and pests. I should have added there one other thing, is better fruit to fiber ratio. I left that one out. More of the edible stuff compared with just the fibers of the plant. Consequently, this also causes expanded geographic range in which plants, including crops, grow, more food for everything that depends on them, and reduced risk of species extinction because the range of these plants increases, and therefore more affordable food for the world's poor. More CO2 is a very good thing. My friend Dr. Craig Idso of the Center for the Study of Carbon Dioxide and Global Change did this study where he concluded, the present study provides a quantitative estimate of the direct monetary benefits conferred by atmospheric CO2 enrichment on both historic and future global crop production. The results indicate that the annual total monetary value of this benefit grew from $18.5 billion in 1961 to over $140 billion by 2011, amounting to a total sum of $3.2 trillion over the 50-year period, 1961 to 2011. Projecting the monetary value of this positive externality forward in time reveals it will likely bestow an additional $9.8 trillion on crop production between now and 2050. All of that CO2, almost all of it, is coming from our use of fossil fuels. And yet we have oil and gas and coal companies saying, oh, we're so sorry that we're putting more CO2 into the atmosphere, but at least we're giving you energy. They should be saying, you know, you pay for energy from us, and we're glad to provide that for you. It makes a huge difference in your life. It keeps you alive. It lengthens your life, all this stuff. But you don't pay us for the added CO2 in the atmosphere. That's a freebie for you. Take it as a gift from us. You're welcome. That's what they should be saying, because more CO2 is 100% good news. All right. Is man-made climate change an existential threat? The IPCC in 2018 published a report called Global Warming of 1.5 degrees Celsius, the impacts of that. Under the no-policy baseline scenario, that is, we do nothing to try to reduce global warming, temperature rises by 3.66 degrees Celsius by 2100 by comparison with before the Industrial Revolution, all right, resulting in a global gross domestic product loss of 2.6%. That sounds like a problem, right? The trouble is they're not telling you compared with what, all right? So the Center for Global Development projects average 3.1% annual growth in gross world product to 2100 to 9.03 times what it is today, or what it was in 2018. The UN Population Division forecasts 10.3 billion population in 2100. So, unrestricted climate change by reducing GWP in 2100 by 2.6% would make the average person in the world only 8.8 times richer than today instead of 9.03 times. Is that a problem? I don't think so. Poverty is a far greater threat than climate and weather, and the poor in this century are getting richer much faster than the rich are getting richer. Okay. Here's a graph of that. The dark blue line here is where gross world product would be if we had zero global warming. The reddish line is where it will be if we have global warming unrestricted by any efforts to slow it down. Is this a catastrophe? I don't think so. But we're told that we have to bring our CO2 emissions to net zero. That is, we extract from the atmosphere as much as we put in. Now, there's no way we're going to extract all the CO2 that we're putting in at this point. So what that means is we have to greatly reduce the CO2 that we put in. John Kerry said that a 2-degree future could result in another 600 million people not getting enough to eat. You notice that word could, right? That's kind of a squishy term in there. I think that there's no likelihood at all that that would happen, but let's assume for a moment that it would, right? Bjorn Lomborg, who is a celebrated economist, says, Half the world's population entirely depends on food grown with synthetic fertilizer produced almost entirely by natural gas. If we rapidly ceased using fossil fuels, 4 billion people would suddenly be without food. He goes on. Additional billions of people depend on fossil fuels for heat, steel, cement, plastics, and transportation. Eliminating fossil fuels, which Kerry wants, would mean depriving people of all those things too. So, he concludes, citing a study by economist Neil Record, the result would be around 6 billion deaths. Lomborg says achieving net zero would cost an average $27 trillion per year, and this is all taking the figures assumed by the proponents of this. He's not disagreeing with them. Would cost an average of $27 trillion a year from now to the end of the century, at which the annual cost would have risen to about $60 trillion per year. Those costs far outweigh any costs from climate change itself. All right, so what gives? Why does the catastrophist narrative prevail? Well, we got a hint at that last September when Dr. Patrick Brown of the Johns Hopkins University said, I just got published in Nature because I stuck to a narrative I knew the editors would like. That's not the way science should work. And he gives us these 4 points for how to do this. You first mention an impact of climate change, but you ignore other contributors. You only talk about what climate change does. You don't talk about other things that might bring about the same impact. This was with regard to a paper that he published in Nature on climate change and wildfires in California. Second, you ignore or downplay actions, adaptation, that can negate the impact. Third, you focus on impressive but not necessarily enlightening numbers. And fourth, you ignore complicating or contradictory evidence. That's why we have the overwhelming media reaction on all this stuff. I'm going to stick with just one quote here. This is the first time in the history of mankind that we are setting ourselves the task of intentionally, within a defined period of time, to change the economic development model that has been reigning for at least 150 years since the Industrial Revolution. Who said that? Christiana Figueres, who was the executive secretary of the UN Framework Convention on Climate Change, at a news conference in 2015 looking forward to the Paris Climate Summit. She is a socialist. Her father was a socialist president of Costa Rica, and her aim is to replace capitalism, free markets, that sort of thing, with socialism, and to replace national sovereignty and multiple governments with global government. That's her aim, and she sees all of this as a path to that. Okay, so that's a quick overview of a little bit of what's in this big book, Climate and Realism, Climate and Energy, the Case for Realism. I think I have about 5 minutes left. Is that correct? That we can take some Q&A. I would encourage you to pick things up. Everything there is informative. I hope that there will be nothing left when I leave. Question and answer.
So who are the primary beneficiaries of what seems to be a very well, broadly coordinated propaganda effort?
Well, for example, China. There are 2 papers over there on how China is playing the West like a violin on this issue. China is doing nothing to reduce its emissions. It is building 2 new coal-fired power plants every week. Its CO2 emissions outweigh all the CO2 emissions of the entire rest of the developed world combined. But China has control of the markets of the main minerals in solar and wind technology. And it is using that to impoverish the West, to enrich itself, to achieve the goal of Chairman Mao in 1949 when he set forth the idea of the 100-year marathon, that by 2049, China would be the world's dominant superpower, far exceeding the U.S. China's benefiting. Solar and wind companies are benefiting. The proponents of population control are benefiting. That is correct. They also control close to 100% of 90% of the rare earth minerals that are indispensable to U.S. defense technology. We depend on imports of those from China.
My understanding of the difference between the Russian climate model and all of the others is the effect of water vapor.
Yes.
Whereas the Russian model assumes a dampening effect.
That's right.
Whereas all the other models assume an amplification
right.
effect. And that explains the difference between their successful predictions.
That's right. If you all have ever heard of runaway feedback or feedback that builds on itself, okay? All of the models, aside from the Russian group, assume that as you put more water vapor into the atmosphere, since water vapor is itself a greenhouse gas, an infrared absorbing gas, as is carbon dioxide, therefore you're going to warm things even more. So as we add CO2, that causes some warming. That warming causes more evaporation, which puts more water vapor in the atmosphere, which warms even further. And so you get this cycle, this vicious cycle of warming. All those models do that except the Russian one. The Russian one says, well, but that increased water vapor in the atmosphere also results in more clouds. And clouds, low-level clouds, cool the surface of the Earth. Stratospheric clouds warm the surface of the Earth. What we see is an increase in the low-level clouds, and that increase more than offsets the warming of the water vapor itself, and so that acts like a thermostat to prevent runaway greenhouse effect, right? The best empirical evidence is that that is exactly so. Dr. Roy Spencer, who's one of our board members and a senior fellow, published back in 2007 a major paper in the Geophysical Research Letters, I think that was the journal, where he had used, because he runs NASA's satellite global temperature observation system, he used the satellites to measure the response of clouds all over the world to changes in temperature down at the surface of the Earth. And what he found was that clouds increase at low level as temperature rises, and they decrease at low level as temperature falls. They do the opposite at high level. Consequently, clouds counter warming and counter cooling, which is a really cool thing. So, one more question. Right here.
I'm not really sure how to ask this, except that is there a way for us to really look closely at what we're hearing to determine, is this fact? Is this fiction? Are there things that you use to look at and automatically say?
Pick up a copy of everything back there. You have to just learn the stuff and then be able to recognize. Certainly our big book, Climate and Energy, The Case for Realism, will help you with a lot of that. There is, in fact, an appendix that lists 40 different major research papers published over the last 120 years that are very relevant to this if you want to read that kind of stuff. It's kind of difficult. But basically, the attitude that says, if I'm being told this is a catastrophe lurking around the corner, just assume it's false. It's not necessarily. I mean, nuclear war might happen, but the overwhelming majority of all the claims of catastrophe around the corner by the Green Movement over the last 100 years have turned out totally false. Okay. Yeah, average crop yields have been rising year by year throughout the period of allegedly human-induced global warming. We're told that warming will decrease agricultural production. It's doing the exact opposite. That was something that we could have learned just by reading history. The medieval warm period of 900 to 1200 was much more productive in crops than the little ice age of 1350 to 1850. So many of these things you just learn if you know some history. Okay, so I'll let you go. Honestly, I want you to take everything away, so please do.
All right. Thank you, Cal.